I'd like to welcome you to the next installment of the Network Security Lecture Series. This lecture will be devoted to protocol and networking hardware. We will learn about the risks related to each of the OSI model layers. To fully appreciate these risks, we will now revise the design of the OSI model. More than 30 years ago, engineers who were creating protocols that are still in use today encountered a serious issue. They had to find a universal way of communication between any two hosts. These may be both modern supercomputers and modern mobile devices. There's a huge gap here when it comes to computational power. Also, the people who designed and created it never met. There have to be some general standards and principles. Successful communication between such devices poses a challenge. Engineers tackled the issue by dividing it into smaller problems. One big task, finding a universal way of communication between any two hosts in the internet, was split into some smaller tasks, 7 to be precise. Each of these tasks is fulfilled by a different layer of the OSI model. We have to know something more than only what's done in each of the layers. The model itself is slightly outdated. It's getting harder and harder to say precisely which function is located in which layer. Very often, the schematic representation of the model shows only 3 layers for simplicity. For us, it's most important to remember that higher layers are dependent upon lower layers. If there's a problem in the physical layer or in the data link layer, you won't find the solution in the presentational layer or the network layer. Individual layers are strongly interconnected. The second important point is that there is a mutual trust between individual layers of the OSI model. For example, protocols of the 4th layer don't check up on the data provided by the 3rd layer protocols. Protocols don't verify incoming data. The next piece of information worth remembering is that each layer communicates only with its immediate neighbors. That's all when it comes to the most important points of the OSI model architecture. Let's have a closer look at each layer. We'll start from the bottom. The physical layer sends a signal through a physical medium. It may be a copper or optical fiber cable or a radio wave. Next, there is a data link layer. It controls access to the medium. It has to take into account various features of the medium. For example, one copper cable cannot transmit 2 signals of the same frequency. Both of these layers lack any kind of security measures, even the simplest ones. Layer 3 is the network layer. It's responsible for the IP addressing and routing. This involves sending packets between networks and transferring them to the destination host. The transport layer is the 4th one. It's responsible for communication channels. Layer 4 allows you to establish a two-way connection. It also enables you to control the session. And contrary to layers 1 and 2, you can implement some security measures in layers 3 and 4. Internet protocols are used for that purpose. Then there is the session layer. This layer may compromise reliable protocols which are connected with managing a session. These are, however, usually implemented in lower layers. A closer look at this layer will show that it includes protocols such as NTLM or Kerberos, which will be discussed in another lecture. The 6th layer of the model is the presentation layer. One of its tasks is data encoding. It's responsible for the delivery and formatting of information to the communication protocols, so they're prepared to be sent. The application layer is the last layer of the model. In this module, we'll see why a successful attack on one of the layers can give the attacker control over the entire computer system. This is another reason for implementing layered security. We will also consider risks and threats connected with each individual OSI layer. We will also examine what kind of measures provide real protection against those threats, and in which circumstances such protection is only illusory. As a summary of all this information, we will try to answer the question: how can you effectively improve the security of your computer networks? Let's start Module 6.